Hello everyone, I am Dr. VRAO-PHYSICAL. In the lecture 53, we have had gone through the concept of corrosion, and we came to know that corrosion is electrochemical in nature, and electrochemical corrosion is considered as anodic dissolution of metal. And moreover, if the corrosion occurs, if the environmental conditions favors the formation of voltaic cell with metal acting as anode, then corrosion occurs. In nutshell, metal getting corroded shall form voltaic cell with another metal or part of itself, right. I repeat, corrosion is electrochemical in nature, and electrochemical corrosion is considered as anodic dissolution, and corrosion occurs if the environmental conditions favors the formation of voltaic cell. Therefore, we can precise, or we can give a single statement that is corrosion if if metal undergoes corrosion, or if the metal getting corroded shall form voltaic cell with another metal or part of itself, right. This type of electrochemical corrosion is of two types, that is what is the first one is hydrogen gas evolution type, and the second one is differential oxygenation type corrosion, right. So, in the lecture 53, we came to know that corrosion is electrochemical in nature, and that electrochemical corrosion is two types, that is, one is hydrogen gas evolution type, corrosion, and the second one is differential oxygenation. Corrosion, right. These are the two types of corrosions. Let us see one by one. Hydrogen gas evolution type corrosion. This type of corrosion is exhibited by metals which can displace hydrogen gas from aqueous solution. I repeat, this type of corrosion exhibited by metals which can displace hydrogen gas from aqueous solution, but this happens only when the potential of the metal is more negative than hydrogen electrode, right. I repeat, this type of corrosion happens only if the metal replaces or metal displaces the hydrogen gas from aqueous solution, and hydrogen gas evolution takes place. When hydrogen gas evolution takes place, if the metal that is potential of the metal is more negative than hydrogen electrode potential, right. And in this context, I shall give you an important note that very important note that the potential of hydrogen electrode depends on pH of the solution and the metal acting as cathode. I repeat, the potential of the hydrogen electrode depends on pH of the solution and the metal acting as cathode, right. For example, the potential of the hydrogen electrode is 0. Potential of hydrogen electrode is almost 0 volts, in 1 molar acid solution, provided if the platinum electrode acts as cathode, right. Platinum electrode acts as cathode, that is already I told you that potential of the hydrogen electrode depends on pH of the solution and the metal that acting as cathode. So, when hydrogen electrode is combined with the platinum electrode as cathode, and the potential of the hydrogen electrode is found to be 0 volts. Potential of the hydrogen electrode is found to be 0 volts. That is potential of the hydrogen electrode in 1 molar acid solution with the platinum as cathode, that would be 0 volts, right. And take another example, and the potential of the hydrogen electrode is 0.8 volts. Potential of the hydrogen electrode is 0.8 volts if the cathode metal is mercury. If the cathode metal is mercury, right. So, if the cathode metal is mercury, then potential of the hydrogen electrode is 0.8 volts. Okay. These are the very important note that you should remember in your mind, right. So, the potential in nutshell, the potential of the hydrogen electrode depends on the pH of the solution and the metal that acting as cathode. Okay. Therefore, now coming to the hydrogen gas evolution type corrosion, this type of corrosion is exhibited by metals which can displace hydrogen gas, but it happens only when the potential of the electrode is more negative than hydrogen electrode, right. Now, let us see. Therefore, we can conclude that in aqueous solutions, pH of the medium and the chemical nature of the metal that undergoes corrosion and the impurity metal that serves as cathode are very important to know whether the metal corrodes or not. I repeat, in aqueous solutions, pH of the medium, okay, one is there are 3 factors which determines decides the whether that particular metal undergoes corrosion or not. What are the 3 factors? One is pH of the medium in aqueous solutions, pH of the medium, and the second one is chemical nature of the electrode that undergoing corrosion, and the third one is impurity metal that serves as cathode. These 3 are very important to know whether the electrode undergoes corrosion or not, right. For example, let us go through the examples. Zinc does not corrode. First example, zinc does not corrode. Zinc does not corrode in salt solution. Because why zinc does not undergo corrosion in salt solution? Usually the salt solution whose pH is neutral, neutral, and there is no hydrogen gas, and there is no H plus ions, and there is there is no possibility to evolution of hydrogen gas in salt solutions. So, zinc does not undergo corrosion in salt solutions, right. So, in more simply we can say that in salt solutions pH is neutral, and when pH is neutral, there is H plus ions and OH minus ions are equal, and there is no H plus ions to there is no H plus ions in salt solutions. So, when there is no H plus ions, there is no possibility to evolution of hydrogen gas. So, zinc does not undergo corrosion in salt solutions. And the second example is if zinc, if copper as impurity, if copper present as impurity in zinc, then zinc undergoes corrosion, right. Okay, zinc undergoes corrosion if copper is present as impurity, How this happens? Because when you go through the, when you recall the electrochemical series, when if you remember the electrochemical series, where zinc has, in that electrochemical series, zinc has more negative electrode potential, that is more negative potential than copper, and copper is present bottom to the hydrogen gas, Okay. So, zinc with more negative electrode potential, and that is ready to undergo corrosion, because it is more ready to, that is zinc with more negative electrode potential, that therefore, that is ready to lose electrons before the copper, right. So, copper is protected by zinc. Copper is being protected by zinc due to zinc undergoes corrosion first than copper, because zinc is readily lost its electrons when compared to copper, because copper is with positive electrode potential, and zinc is with more what is it called, negative electrode potential. And the third one is zinc undergoes corrosion. Zinc undergoes corrosion in 2 molar acid solution, right. And again, zinc undergoes corrosion in 2 molar acid solution, usually 2 molar acid solution whose pH is less than 7, and there are H plus ions to evaluate the hydrogen gas. So, usually zinc undergoes corrosion in 2 molar acid solution. So, in aqueous solutions, in hydrogen gas evolution type corrosion, there is an important point, that is in aqueous solutions, pH of the medium and chemical nature of the electrode that is undergoing corrosion, and the third one is the metal that serves as cathode are very important to know whether the metal undergo corrosion or not, right. So, this is about hydrogen gas evolution corrosion, right. And the second one is differential oxygenation corrosion. Differential oxygenation corrosion. For example, if oxygen concentration on the surface of the metal is not uniform, I repeat, if the oxygen concentration is not uniform on the surface of the metal, then there may be corrosion takes place at the point where the oxygen concentration is less. I repeat, if the oxygen concentration is not uniform on the surface of the metal, then there may be corrosion takes place at the point where oxygen concentration is less. Right. This is because of the point at which oxygen concentration is less acts as anode, and the point at which the oxygen concentration is high acts as cathode. Therefore, metal with differential oxygenation acts as voltaic cell, and that undergoes corrosion, and corrosion occurs at the point where oxygen concentration is less. Therefore, in nutshell, we can summarize this statement as with a single statement, that is metal with non-uniform concentration of oxygen may undergo corrosion, or there occurs corrosion. Corrosion occurs at the point where oxygen concentration is less, because the point at which oxygen concentration is less acts as cathode, and the acts as anode, and the point at which hydrogen that is oxygen concentration is high acts as cathode, right. So, these are the very important things, that determining the differential oxygenation process. Okay. So, the point at which oxygen concentration is more acts as cathode, and the point at which oxygen concentration is less acts as anode. Okay. So, high concentration of oxygen high concentration of oxygen acts as cathode, and low concentration of oxygen acts as anode, right. The metal or the for example, if the oxygen concentration on the surface of the metal is not uniform, then that metal undergoes corrosion at the point where the oxygen concentration is low, and the point where the oxygen concentration is low acts as anode, and the point where oxygen concentration is high acts as cathode. So, metal with differential oxygenation or that is metal with differential oxygenation acts as voltaic cell, and that undergoes corrosion, right. So, we can applicate this concept to the number of examples. Okay, I hope you all understand this lecture. I hope you all understand this lecture. If you really like this video, please extend your support by like, share, comment and subscribe. Thank you for watching.